Okay, so that we can work a bit quicker here, I'm just going to delete a few of these agents. If I just drop a delete here and make a quick group, not a group, but just delete this box here. Let's do bounding box and find the box. You don't have to do this if you don't want to, it's just so I can work a bit quicker. And then the size needs to be bigger. Just do that, delete non-selected. Then I just get these agents here. Okay, so I'm going to dive in here now. Back inside. And then let's drop. So what we're going to use are these pop curve force. So we can connect that up to the middle port. Okay, and then find that curve that the same as this root. So out curve, yeah. And then we can see something there already. So we can generate forces within these bounds, the bounds of this, what you can see, the red part there. Okay, so the radius there, that will be where we can actually have an effect on the points inside. Okay, and then the main things are these kind of forces here. So the follow scale will follow in the direction. You've got these handy arrows which show you the direction, so this will push the points in this direction with this force. We've got a suction scale which will push the points in this direction. Okay, and then an orbit scale which will cause the points to spin around. So we need all three working here, right? So let's see, I'm gonna just first set these up. So I'm gonna put follow to 30, suction to 10, and on orbit I've got 50. Okay, to start off with, and turn off ignore mass, and let's just see what that gets us. Right, so I didn't run a flipbook, I just let a few frames simulate there. So I'm just going to zoom in here and just show you what we've got so far, to see that working. Okay, so you can see them getting sucked in and spinning around and going up a bit as well. Okay, but I want a bit more control over this. Okay, I want to add some randomness to all of that, to those forces. Also, when they get sucked up, I don't want them to just go up and then just fly out the top. I want them to, the force to die down as it gets to the top. Okay, so there's a few things we need to do to control that. At the bottom here, we got some curves that we can use to control them as well. But for most of these, I'm just going to set them all to like a constant value, because I'm going to control it with the Vex expression here. Okay, so just that there's no crossover between them. Okay, and global forces, you've got a global fall off along the curve, from the curve, sorry. So the further you are away from the curve, the less the force for all of them together. We'll leave that as it is, like that, on without any effect. And then the force along the length from bottom to top, that means it will weaken from the bottom going up. Okay, and again, I don't want any I don't want that at all, so I'm just going to delete. Well, I'll just put this value to 1 on this. So there we go. Okay, and shaping, you can give it a bit more of a tornado shape, like that. Okay, drop this down 0.7. So there's kind of got more of that like cone kind of shape. Okay, so I'm going to use some Vex expressions here. So this doesn't help too much, but it has this pass-through thing, which just tells you, how to use. Oh, why did I do that? Put that in again. So it gives you the names of these parameters, basically, right? So what we're going to do here, let me try, first of all, I'm going to set up with the scale follow. I'll delete this, don't really need it. So scale follow, as I said, I want it to get weaker towards the top, all right? So I'm going to set up this just a fit and basing that on the position, right? So I'm going to grab the position in Y, and then so from 0 to about 30, which is roughly the height of the tornado, and then the force will be from 50 to 5. So at the top, the follow will be 5, and then at the bottom it will be 50. So we'll have a stronger force, and then as they get to the top, it gets a bit weaker. Okay, so that should work fine for us like that. So what else? I want to randomize these forces. Okay, so I'll set up the random values first, and I'm going to do a different one for each force, so that they don't. So basically, if I have some with the strongest orbit scale, I don't want the same ones, all of the same ones, to have the strongest suction scale. You know, I want it all to be a different random number for each force, basically. Okay, so I'm going to set them up first. So let's do a float rand orbit first. Will be fit, not fit, sorry. Will be rand of the ID, so we get an ID from the pop source, and then we'll add a kind of like a seed which will be different for each one. Okay, so yeah, I think in the pop source, let's just double check. Here it should be on by default. Add ID attribute. Okay, so each agent will have an ID. So back in here, so we've got a random number for the orbit strength. We haven't done anything with that yet. So I'm just going to copy and paste this 2 more times, I think. Whoops. Okay, so we got random orbit. I also want a rand suction. Okay, and for this we'll just do 20 there, and then also for follow as well, round follow, and for this I'll do plus 30. Okay, just so that they've got, so we got different rand values, and these are the attributes. Okay, so let's set up some if statements. So if the rand orbit is more than 0.5, so this way I just grab half of them, then scale orbit times equals I'm going to do 1.2. Okay, so that scale orbit is this, where are you, this value. Okay, so half of the agents will have this value multiplied by 1.2. Okay, so they'll basically have a value of 70. I think, yeah, if that makes sense. Okay, and then we'll do the same with this for the others. So scale orbit, let's do scale if rand suction is more than 0.5. We'll do the same thing. Scale suction like that. So let's just double check. Okay, is multiplied by 1.2, half of them again, and then the same for the follow. okay, is I'm going to do, if they are less than 0.4, so a bit less of them, scale suction is multiplied by 0.5, so I want less, you know, half of, so there'll be 25 basically. Okay, and that should do us. So, oh, we've obviously forgotten to drop in the brackets. Can't forget the brackets, need to be neat. And okay, so no more error. So that should be all. So let's run a flipbook on that. So I won't do it from the camera. Let's do it from here. And just see if we get anything, see if that works. Just going to cancel that flipbook so I can see the camera's no good. Just zoom out a bit. Escape. Let's go into full screen. There we go. Go closer like that. There we go. Right, so got a fair few frames there just to see what's going on. So we can see them getting sucked in, spinning around, staying inside. Well, some staying in, some getting kind of spat out the back. I think as the tornado starts to move, they start to fly out the back. But then it's also picking up these agents here as well, which are on the ground, which is cool. Okay, so we're kind of on the right track at the moment. We also need to, I'm going to add another force to kind of suck in more agents just at the bottom, and maybe add some noise and drag to that as well.